Yeah, so my name is Matt Honeycutt. Today in this session we're going to be looking at doing some test-driven development. And towards the end we're going to look at the SpecsFor framework, which is a testing library that I've ended up evolving out of a couple of different applications. But yeah, we're going to look at that and how that can help improve your test-driven development workflow. It's a framework that's kind of designed to optimize developer productivity and help you write some kind of BDD style unit tests, some behavior-driven development style if you're familiar with that language. But we're going to start just bare bones. We're going to start at test-driven development ground zero. Just starting out, this is how you get started. And of course, got to thank the sponsors, RecruitWise, and we're in room 413A if you want to send any feedback to the CodeStock handle on Twitter, and Cadre 5. So thanks to them for making CodeStock possible. All right, so let's get started. Let's do some test-driven development. So this is our boss. This is Baron von Kitty. I actually had it in my head. I knew what I wanted to represent. Knew what image I wanted for our boss when I was getting ready to start putting this presentation together. I went to Flickr and searched for like cat with monocle, and this was the only result that came up, and it was exactly what was in my head. This is exactly what I pictured. So the internet wins again. So our boss, Baron von Kitty, he wants in on this app store money. He's heard about this app store and he wants in on the money. So he thinks that if we build a calculator that takes in a string of numbers and adds them up, he thinks he'll make all kinds of money. So he wants us to build a string calculator, put it up on the App Store, and make lots of money with it. So anybody familiar with the string calculator kata, test-driven development, or Ashra? No? Yep. Okay, got one person. Yeah, so that's basically what we're going to run through. We're going to run through his kata in just kind of a more fun manner. So our string calculator has pretty simple requirements. Users can enter a list of numbers. It could be 0 numbers all the way up to n numbers. The numbers are going to be comma delimited, so there'll be a comma between each number. And all string calculator has to do is add the numbers up and return the result. And it also does have to make lots of money. There's no point in building it if it doesn't make lots of money, right? Because that's what Baron von Kitty wants. He wants his money. He wants his movie check. All right, so fortunately, Baron von Kitty is going to help us do test-driven development. He's going to let us write the code we want to write it. And he's going to kind of feed us requirements one at a time, starting with the simplest requirement first. And we're going to do test-driven development to implement the requirements. So the simplest requirement for string calculator is the user could input an empty string. And when that happens, we just want to return 0. So that's the first thing we need to implement. So we'll go over to Visual Studio, and I've already set up a project, a solution. So I've got my string calculator core project, and that's got my actual calculator in it. And then I've made a separate project, a separate class library that's going to actually contain my unit tests. So let's split the window here. So first thing we have to do before we write a unit test is we have to pick a framework. So there's lots of different frameworks that you can use for writing unit tests. My personal favorite is NUnit. So if I'm going to do unit testing, I use NUnit. There is, in the box, Visual Studio comes with the Microsoft Test Framework. I'm not a big fan. I know people that use it and they get by with it okay. Personally, I wouldn't use it. If you're going to do test-driven, if you're going to do unit testing, go with NUnit. You'll find that there's much better support from the community for NUnit than there is for the Microsoft Test Framework. Excuse me? Yeah. There's a ton of different testing frameworks. There's XVal, there's MSpec, there's all these different ones. I don't really, I don't want to debate the pros and cons of each one. For me, NUnit does everything I needed it to do. Definitely look at the others. You may find something that one does that you like, and go with that one instead. I would still kind of caution you not to go with the Microsoft version. Go with one of the open source versions. All right, so we want to get started with doing some unit testing. Fortunately, we have NuGet, so it's really easy to get up and running now. So we're just going to add a package reference to our string calculator. And if the internet craps out, I do have a backup, so we'll see how long this takes to load. There we go. Okay, so we're going to install NUnit. So you just go to add library package reference, search for NUnit, install. And that's it. So now I have NUnit added as a reference. It adds a couple other references which you don't have to have. I'm going to take those out. So I have NUnit. And in NUnit, the NuGet package actually comes with a test runner. If you go to the NuGet package in the tools folder, there's actually a GUI that you can use to run your unit tests. I like to have something that's a little bit more integrated in Visual Studio. So I've got 2 add-ins installed that will let me run unit tests. One is Resharper. So if you have Resharper, you actually already have a test runner that can run in-unit tests. The other one is testdriven.net. That's the one that I prefer. That one, you can actually use it to run a lot more than unit tests. You can pretty much right-click on any method as long as it doesn't require parameters and say run, and it will run it just right there. So it's pretty cool. Test-driven is the one I like, but find a tool that runs unit tests that works for you. Whatever works best for you is what you should use. All right, so the first thing, if we want to make a new unit test or a test case, the first thing we have to do is make a test fixture. For in-unit, a test fixture is just a public class. It's marked with the test fixture attribute. So all we have to do is just tag it, test fixture. Now our calculator specs class is an in-unit test fixture, which means we can put test cases in it. So one of the most important parts of writing a new test case is deciding on the name. So it doesn't seem like much, it's really, we're just creating a method, we're going to tag an attribute to it to make it a test case. That method name is actually really important. That's going to tell us what we're going to write code to test. So if we go back to Baron von Kitty, he's telling us if the user inputs an empty string, the calculator should return 0. So we're going to make a test case adding an empty string returns 0. All right. And we've got to remember to flag this with the test attribute. If you don't do that and then you run the test fixture in, it's just going to skip over it. So to make a test case, you just have to make a public method that returns void and tag it with test. That's all you have to do. Now it's a test case. All right, so now I'm just going to write code to verify the correct behavior of calculator. So we're going to make a new instance of the calculator. And I'm going to use Resharper to go ahead and pull in the reference. And what we want to have happen is when we call calculator.add with an empty string, we want it to return 0. So we're going to use in units assert class. This is a static class that has methods to assert that certain things are true or false or whatever about our objects. In this case, we want to assert that the sum is equal to 0. So you'll notice that this code actually does not compile, right? So if I try to run this test, I get a build error, right? Because there is no add method on our calculator. That's good. Having split screen or split views worked a lot better when I had a bigger projector. But anyway, so yeah, this is actually good. We want to start with a test case that does not work, a test case that fails. Not compiling is a state of failure, right? So we'll go ahead and we'll write the bare minimum of code to make this test compile. So we're going to use Resharper. We're going to add the add method. And we want to make this return something and then verify that our test fails. So even though our code now compiles, we still want to see our test fail, but we want to see it fail for the right reason. I want to see this test fail when calculator returns something besides 0. So a test is a lot like a backup plan. It's worthless until you actually have to use it. So I want to see this test actually fail. That way I know the test is testing what I want it to test. So let's run the tests. And great, the test works. It caught the fact that we returned a -1 from the calculator when we were really expecting a 0. So now we get to actually write some real code. So what is the simplest possible thing we could do to make that test case pass? Return 0, that's right. 0. We could do something more complicated, but we don't have tests that drive that. We have no tests that say we need a more complicated solution right now. This is all we need. And our one test will pass. And this is perfect. This is exactly what we want to do in test-driven development. We want to start with a simple test, as simple as we can possibly make it. We want to verify that that test fails for the right reason. And that part's important. We want to be sure that we fail for the reason we were expecting to. Then we write just the bare minimum of code to make that test pass without breaking any of our existing tests. So we've done that. At this point, we have 2 options. One of those options is not to flesh out this add method. We can't do anything else here. other than refactor it. We could refactor this code if we wanted to, if we had enough code here, if we saw some way to restructure the code, reorganize things to improve it without actually changing the behavior. We could do that. We can't write any new code here though. We can't add new functionality. Our only other option is to make a new test that fails. So let's go back to our cat. Our next requirement is when the user inputs a 1, we're going to return 1. So it's pretty simple. Again, we need to choose a good test name. So public void adding 1 returns 1. So our test method tells us exactly what we're going to test. I do like using English readable test names. I think that's you'll get better output from your build server, and it just kind of helps guide the structure of your actual test. It tells you this is what my test is going to do. So I'm going to make a new calculator. And we're going to add a string containing just the number 1. And then we want to assert, and I'm actually going to change. NUnit's pretty flexible. There's a lot of different helpers on the assert class. I'm going to switch to a different one that I like a little bit better. So instead of saying assert r equal 1 sum, which I don't think really reads all that well, I'm going to use the that method. Assert that sum is equal to 1. So this is exactly the same as if I had written assert r equal 1 sum. I just think that the second approach, using assert.that, reads a little bit better. So that's typically, if I'm going to use the assert class, I'll use that helper instead of r equal or something like that. All right, so we have a new test case. We're gonna run it first before we do anything else. And the test fails for the right reason. We passed in 1. We expected to get 1 as output, but we got 0. So our test is failing. It's going to catch what we intended it to catch. So we come back here, and what's the bare minimum of code we can write to make our tests pass now? Well, we can say if input is an empty string, return 0. Otherwise, return 1. Run our tests, and our tests pass. So we added just the bare minimum logic we had to add in order to get that test to pass. And we're going to look at our code. We have two options again, right? We can't write new code in our calculator.add, not until we have a failing test. We could refactor that code, but there's not enough there really to refactor. So we're not going to do anything there. We are going to refactor our tests a little bit. So just to be consistent, we're going to replace this assert r equal with assert.that sum is equal to 0. And we're going to make sure our tests still pass. All right, so at this point we need to write another failing test. So we'll go back to our boss, Baron Von Kitty, and ask him for our next requirement. So the next requirement, when the user inputs 2, we should get back 2. That should be what the calculator returns. So again, this is a really simple requirement, but this is the approach that we want to take with test-driven development. We want to build very incrementally. Build out just the next simplest test that we can to enable us to write just this small piece of functionality. So make a new test case, adding 2 returns 2. Calc equals new calculator. So we're going to add a string containing 2, and we're going to assert that the sum is equal to 2. All right, again, we're going to run our unit tests. 2 of our tests still pass, 1 of them fails, and we can jump to that line if we need to, but yep, the test is failing for exactly the right reason. So now we can go over to our calculator, and we can make the simplest change possible in order to make that test pass. In this case, we're going to swap out this literal 1 with an int.parse. All right, and we're going to run our test, make sure we didn't break any existing functionality. All our tests pass. So again, we have 2 choices here. We can refactor our code, or we can move on to the next requirement. So let's go ahead and let's do a little bit of refactoring. Anybody in here familiar with the should library? Anybody heard of that? You got one hand? That's it? Yeah, okay. So I'm a big fan of should. I don't assert that sum is equal to 0. It just doesn't read right to me. I'd much rather write code that looks like sum should equal 0. I'd much rather write something that looks like that. And that's exactly what the should library will let me do. So come back to NuGet, and should is on NuGet, so if you've got NuGet installed, just go and find the package on there and install it, and use Resharper to pull in the extensions. And now I can replace my assert.that, these kind of, poorly reading statements with methods from should, extension methods from should that read a lot better. So sum should equal 1, and excuse me? Should will work with anything. Yeah, should will actually work with anything. It throws its own custom exception type, so yeah, you can use it with any testing framework. All right, and we just did some refactoring, right? We replaced some functionality we replaced one function call with another. So let's run it and make sure our tests still pass. They still pass, so we're ready for a new requirement. All right, so now we're getting good. So now the user's going to input 2 numbers separated by a comma. So we need to handle that. User inputs 1, 2. We need to output a 3. I have no idea why he's smoking a pipe now, but he looks evil. All right, so public void adding 1 and 2 returns 3. All right. One, 2, and we're going to say the sum should equal 3. All right, and we're going to run our test, and it blew up with an exception. So input string was not in the correct format. That's because we just tried to call n.parse on a string that's got a comma in it, and it does not like that. So again, we have a failing test, so we can write some new code here. So we need to handle the simplest possible thing we can. So we'll write code that only handles the case of the user inputting exactly 2 numbers. So input.contains. So if input contains a comma, we'll assume that there's only 2 numbers. That's all there can be. And really, if we're going to do TDD, fully, if we're going to really stick to this kata, that's all we would do. We would just say return 3, because that's all we need to make that test pass, to make all our tests pass. Since we're limited on time, we're going to shortcut just a little bit. And what we're going to do instead is that we're going to actually handle the case of 2 numbers. So we're going to grab the pieces of that string. So we're going to split it using the string split method. So we've got our parts, and we're going to use int.parse, parse each piece of that, and return the sum. And run our tests. We have 4 passing tests. So once again, we can ask ourselves, do we want to write another test, or do we want to do some refactoring? So let's look at we're starting to get some cruft over here, some stuff that we could pick up, we could encapsulate, maybe clean up a little bit. But we'll leave it alone for right now. We're actually going to do some heavy refactoring in just a second on this. Let's look at the tests, though. So there's a little bit of repetition starting to show up in our tests. There's one line in particular that's in every single one of our tests, and that's the var calc equals new calculator. So that's showing up in every single one of our tests. So what's going to happen if our calculator suddenly takes on a requirement, a dependency on another object, and we now have to supply that object through dependency or constructor injection? Now we're going to have to go in and edit every single one of our tests to update the constructor call, right? We're going to have to pass that in everywhere. So what I like to do is encapsulate the creation of whatever class I'm testing in a setup method. So public void create calculator. And NUnit has a setup attribute that you can tag to a method. And what this says is run this method before each one of our tests. So before it runs our adding an empty string return 0 test case, it's going to run create calculator. It's going to run create calculator again before it calls adding 1 returns 1. So this is a good place to initialize whatever class you're going to test. I like to store the class that I'm going to test in a field, and by convention I usually name it SUT. What that stands for is system under test. That's a convention that you'll see in some open source frameworks. It's not a real widespread convention, but I've used it, just kind of picked it up from other projects I've worked on and found that it works well. This way, in every single one of my test fixtures, if I stick with this, my object that I'm testing is going to have the exact same name. It doesn't matter what I'm testing, it's always going to be SUT. That's going to be the class I'm testing. So we're going to initialize this guy to a new calculator, and we're going to store this. This is going to be a field. And now we're going to take out that line from every one of our tests. And we are going to use Resharper to fix that for us. So now all of our test cases are using this shared system under test calculator. And it's not like they're using the same instance, because this setup method is called each time. Each one of our test cases is actually getting a brand new calculator. So we don't have to worry about, if one of our tests affects the state of whatever we're testing, they're going to get a brand new one initialized from scratch every time. So let's go ahead and run our tests, make sure it still passes. And it does. So we're ready for our next requirement. So we're getting a little more complicated. So the user's going to input 3 numbers, 1, 2, 3, and the output should be 6. So let's make our test case. So public void adding 1, 2, 3, return 6. So our sum is going to be 2, 3, and we expect our sum to be equal to 6. So adding 1, 2, 3 returns 6, and when we run this, it actually returns 3, which is good. So we satisfied the first requirement. We have a failing test now, so we can use this failing test to drive new functionality in our calculator class. So we go back to calculator, and it's failing because our class really can only handle up to 2 numbers. So we need to make this a little bit more robust. We need to be able to handle n numbers coming in as input. So let's make this a little bit more complicated. Let's make a sum variable, and let's loop through each of those parts, and let's add it to our sum. So parse. So we're building up a sum. Pretty simple, right? We're just looping through the pieces of our input string after we split it. We're parsing each of them, adding it to a sum, and we're going to return that sum. And all our tests pass. All right, so at this point we have 2 options again, right? We can make another failing test to drive some new functionality, or we can look at refactoring our calculator. We can look at refactoring this add method to simplify and clean things up. And this guy is getting pretty ugly, right? There's quite a bit of code in here that's, even Resharper is telling us that, hey, we can simplify things. Resharper is telling us we can convert this for each into a link expression. That right there just cleaned up a lot. Run our tests again, make sure they still pass, and they do. And let's see, actually, we can collapse these 2 code paths, right? Right now we have 2 returns. We can actually collapse this and handle both cases, both a single number and more than one number with a single path of execution. So we can actually take this out. And if we run this right now, we're actually going to get that's right. So yeah, that actually works fine. Say we tried to do this. Say we think that this will actually handle, the case of the empty string too. Let's take that out, run it, and one of our tests fails. So if we go and look at it, we've actually broken existing functionality. We're no longer handling adding an empty string. So that's great. So let's go back and look. How can we fix that? So the string split method has an overload that allows you to specify what to do when splitting a string results in the creation of empty strings. So we have to use a slightly different overload, but what we're going to tell it is when you split the string, if you have an empty string, if splitting the string makes any empty strings, then don't return them. Just remove the empty entries. So what's going to happen now is when we pass in an empty string, calling split on it is going to would return an empty string. Now it's not going to return anything. It's just going to return an empty array. We're going to call sum on an empty array, which is going to just return 0, I think. Let's test it and make sure. All right, so our test passed. So we just did some heavy refactoring on this add method. And we had the confidence to do that because we had test cases around everything. We knew if we broke existing functionality, one of our tests would fail, and it would tell us. And we know that we've arrived at the simplest possible solution that we can for this particular set of requirements we were given because we built only the bare minimum to make our tests pass. There's no extraneous code here. It's the bare minimum, hopefully the simplest solution that we can come up with for the 5 requirements we've been given so far.
At what point do you put some try-catching logic in the method itself?
In the method itself. So, okay, the question is, at what point do you start adding error handling to your method, right? So, it kind of depends. One approach would be, Baron von Kitty didn't tell us to do error handling, so forget it. We're not going to do error handling. We're just going to let it blow up. But we're good developers, though. We know that's not good practice. So what we should probably do is write some test cases to handle different error cases. Things that we can think of. Well, what if the user passes in a null? We need to handle that. Or what if they pass in 2 commas to separate things? We need to handle that. Some of that we can think of, and we could make test cases to expose those, and then we'll write test cases to be sure things are either handled or that it correctly throws the exception we're expecting. So we could do that. We can also go back to our product owner, in this case, Baron von Kitty, and we can ask him how important error handling is. He may come back and say, no, you don't have to worry about that. Higher up, whatever service is going to call this string calculator we're building, it's not going to let an empty string or a null string come in. It's not going to let the user input, 2 commas together. All that stuff's being handled higher up the stack, so you don't even have to worry about it. It kind of depends on, the situation, but I'd lean towards, depending on what you're implementing, working with the product owner to figure out what error handling do you actually need. That way you implement just the bare minimum to satisfy business requirements. Product owner is not always going to know what error handling makes sense, so you got to negotiate with them a little bit. And some things you'll just add because it makes sense, but you won't actually add any error handling until you have a test case to expose what you want to write error handling for. Make sense? All right, so let's get another requirement. So Baron von Kitty doesn't like negative numbers. He does not want string calculator to let users add negative numbers. So how are we going to verify that our calculator does not allow adding negative numbers? What we're going to do is assume that it should throw an exception. So adding negative number throws exception. And I'm kind of cheating a little bit on the kata. I should be implementing a little bit more piecemeal, but just for the sake of time, we're kind of going through these a little bit faster than you probably should. What we're going to do is we're going to use assert throws. Let's say we expect it to throw an invalid operation exception. Now we pass in an expression for whatever code we want to test to verify that it actually throws an exception. So in this case, when we call add with a negative number, we expect it to throw an invalid operation exception. So if we run this, it tells us that we expected an invalid operation exception, but what we actually got was null. So what that actually says is the exception wasn't thrown. There was no exception thrown. So we have a failing test, so now we can go implement that. So what is the simplest possible way we could implement that check for a negative number? Yep, we can just do if input.contains the minus sign, throw new invalid operation exception. Run our tests, everything still passes. So that's not, you're right, that's not the best solution to that problem, but for right now, that satisfies our test. So if we wanted to add in some more robust checking for negative numbers, we would need to make a test case first that exposes why we need that more robust error checking. So in this case, we're going to skip that because, time being what it is. So let's go back to Baron von Kitty. And we've had this, let's say we released it to the App Store, but he's not really making a lot of money, so he's like, okay, let's add some new features. So in addition to returning the number when the user passes in a string, let's also go ahead and write that to the console. So let's write to the console whatever the sum is in addition to returning it. So let's make our test case. So public void adding 0 writes 0 to the console. Alright, so our sum equals add, say we pass in a string containing 0, and what do we do? So at this point we want to check and see what was written to the console. So how do we do that? Any thoughts? So remember the console class, that's a static class, and WriteLine is a static method on that class. What we're wanting to do here is we're wanting to check and see, Did the calculator actually call console.WriteLine and pass in a 0? That's what we're wanting to check here. How are we going to do that? Well, we could introduce an abstraction. So instead of writing directly to the console, we could have our calculator take in some console service, some interface that our console service is going to implement, and have all calls to the console go through this interface, through this abstraction. That opens up the opportunity for us to start testing that interaction. We could, at that point, then build up a class for testing that implements that same interface, and we could start adding in some logic to check and make sure it's called. That gets really nasty really quick. So what we're going to do instead is assume that we've got some framework that will let us write code like mock console.verify that console.WriteLine 0 was called. We want to be able to write code that looks like this, so that we can say, given some console, calling add actually called WriteLine with 0 as the input parameter. There's actually a framework that will let us do this. So we're going to go back to NuGet. We're going to add the mock framework. Mock, or sometimes pronounced mock-Q. This is a mocking framework. So what this allows us to do is create new types at runtime and then verify. Basically, we can say mock, create some type that implements this interface. I'm going to grab that, pass it in where this interface is expected, and then after the fact, I can use mock to see what actually happened to the class that was dynamically built. So I can make a mock console object. So it's going to be mock. And we are going to introduce an abstraction. We're going to introduce an iConsole abstraction. And for the sake of time, we'll go ahead and implement this over here. So we've got our iConsole interface. We're going to make a mock for that console. And it's probably not clear if you haven't used mock before what's actually going on here, but we'll look at it in just a second. Oh, cool. So I still have a failing test because my code doesn't compile, so that's good. Remember, that's not a bad thing. So that's because my console, that interface I just added, does not actually have a WriteLine method. So it's impossible for the calculator to call that if it doesn't exist. So we'll go ahead and make that method and add that to our interface. All right, so now if we run our tests, we get an error that says we expected console.WriteLine with a parameter of 0 to be called, but nothing was actually called. Nothing at all was called on our console object. So we just, at runtime, had mock build up some type that implements this iConsole interface, and then we asked mock, did anything actually call the WriteLine method on that interface? And mock said no, nothing called WriteLine. Well, that's because calculator has no dependency on iConsole. It's not getting a reference to mock console, so of course it can't actually access it. So let's go ahead and let's say that calculator is going to use dependency injection, constructor injection. So we're going to inject this dependency on console. We use Resharper to add that to the constructor. All right. So our calculator now has a reference to iConsole. What we're passing in our test is actually this mock console. So it implements this iConsole interface, but we didn't have to explicitly make a new type that implements that interface or anything like that. We're letting mock build that up for us at runtime. So we can run our tests again. Our test will still fail for the same reason. We're passing that dependency in, but we're not actually calling it yet. There's nothing in the calculator that's calling it. So let's do that. Let's use Resharper. We'll move this to a variable. And let's log that to the console. So run my test now, and my test passes, right? So that's because when calculator called WriteLine is actually calling WriteLine on our mock console object here, that thing is recording every single call that comes into it. So it's keeping a list of every call that comes into it. So now when we call verify, verify that WriteLine was called with a parameter of 0. It's going to look at everything that was called on it on our mock console. It's going to see that WriteLine was called with an argument of 0, and the check's going to pass. So our test is going to pass. So mock is a very, very useful framework for testing interactions like this. Yes, question?
What if what Baron meant was the console that we thought he meant in the beginning, and he says, well, that's not necessarily, this is probably splitting hairs. That's okay.
Mm-hmm.
I didn't actually, there's no way of testing that there's something written to the console that I was referring to. Does that make sense?
Yeah, so you want an integration test to verify that at the end of the day, it's actually writing that number to the console.
Okay,
that
so you call that, you can differentiate that as an integration test.
Yep, that's where I draw the line. So, yeah, that gets into kind of a religious debate about, what kind of testing you should do. Yeah, there's a difference between a unit test, which is basically it's a test that's isolated at the boundaries of whatever you're testing, versus an integration test, which actually tests behavior across multiple classes working together. So you still want integration tests. There's actually a way that you could write an integration style test around this and verify that the thing you expected was actually written to the console. But in this case, since we're just doing unit testing, we just care about that interaction. Yep, good question. Anything else?
That's the clearest differentiation I've heard of that.
Oh, cool. Yeah, and it is. It's kind of a religious debate about which one has more value, unit testing versus integration testing. Mm-hmm. Mm-hmm. So the question is, like, if, say I'm doing ASP.NET or something like that, and I want to unit test my view, right? Yeah, so the view itself is not directly testable, not with this style of testing. You can test parts of the view. So if you have like HTML helpers, you can write unit tests around those things to make sure they're behaving the way you expect. But the view itself, you can't really test in a unit testing style because that view by nature is generated from a whole suite of things working together, right? So that's really, you can make an integration test that will test that. You have to get into like browser automation and looking at some of those tools. So it's not something that you can do out of the box just within unit, even if you pull in mock or something like that.
There are cases where we like to find it out should we even consider even that to do that to be part of the testing?
I think you do want automated tests for those things. I do think if you can automate, basically you're talking about automated acceptance testing at that point. I think that's a great thing. That's a more advanced concept that's beyond unit testing really. But you can take some of the same kinds of approaches. But yeah, I think that's, if you can do it, if you have the resources to do it, then absolutely do it. The thing you have to be careful about it when you start looking at automated acceptance testing of like web frameworks is you don't want your test to be so brittle that somebody just moving something around on the form breaks your unit test. Your test should not restrict you from making, refactoring and stuff like that, from making incremental improvements. If your tests become a barrier to that, your tests don't have a lot of value. So it's tough to find that balance from what I've seen if you start trying to do automated acceptance tests. How do you make good tests without making them so brittle that you don't feel safe working in your application because you're going to break 50 tests every little change you make? But, yep, good question. All right, so let's do a little more interaction testing. So we've got the app, the new version's out on the App Store, and we're still not getting a lot of money. So Baron von Kitty wants us to start recording every time somebody calls the string calculator. That way we know how often it's being used. So let's go back. Let's make a failing test. So adding numbers records the input and output. So we're going to record the input and output to a transaction log every single time the number is added. So our test is going to look like, really doesn't matter what we pass in here, right? Could be any input really because this is a generic requirement. But what we want to have happen is to verify that some transaction service received a call that says record this, the calculator was called with these values. So again, we're going to fall back and use mock. So mock transactions, we're going to verify that t.record was called with the parameters 1 and 3, and we also want to record the output, so 4. So we want something that's going to look like this, and we want to verify that calling add actually resulted in a call like this on our transaction service. So let's go ahead and, Right, so we got failing code, or code that doesn't compile. That's great. So let's make it at least compile. So let's make a transaction service. Transactions. And I could use Resharper to go ahead and generate this, but it actually generates it in the unit test project, and then you got to move it. And for the sake of time, it's faster just to do this. All right, so I have my transactions interface. I'm going to go ahead and initialize that mock object. All right, and make sure my test fails. Actually, yep, still fails because it doesn't compile. We got to add this method. So record string input sum. Yep, our test fails. Obviously, we haven't implemented the code yet. Nothing's calling record. But this at least tells us that our test is testing the right thing. You know, it's failing for the right reason because nothing is actually recording that transaction yet. So let's go ahead and we'll again use constructor injection. We'll pass in that transaction to our calculator. So mock transactions.object. When we call .object, so this mock transactions here, when we call object, we're actually saying, give us the underlying object that you built up at runtime that you're going to record calls for. So that's really giving us the object that implements iTransactions. Add that parameter to our calculator constructor. And store it in a field. At this point, we're ready to actually make that test pass. So transactions.record. Input sum. And again, if we were doing, if we were really sticking to test-driven development, we would actually make this solve with make this pass with a simpler case first. We'd start out passing in literals here. We refactor it as we added additional test cases to pass in, what we really wanted our final state for the code to be. For the sake of time, I'm shortcutting that. All right, so we have a passing test. So we can refactor code, or we can go back and write some more tests. So got one more. So Baron Von Kitty wants us to tell the user that they actually owe us money. So he thinks that's why we're not getting paid. People don't realize they've got to pay for string calculators. So let's look at how we can write a test for that. So we're going to reuse that same console, that mock console. Adding numbers, writes message to the console. And at this point, we really don't even care what it returns. So we just care that we call the add, we pass in whatever. What we really care about is that the console was called, and that some message was passed in. So Baron Von Kitty gave us this message. This is the wording that he wants in there. You owe us money. So run our test. And it tells us, WriteLine wasn't called with that. It does tell us how WriteLine was called. It says console.WriteLine was called with a value of 6. So that's from our other requirement that we already implemented, where we're writing the sum to the console. So mock is telling us that, hey, it was called, just not in the way that you set up an expectation for. So let's make this pass. You owe us money. All right. All our tests pass. So, any questions on that so far? That's kind of the general test-driven development, pattern. You start out with a test that fails, and it fails for the right reason. You want to be sure that it actually fails for the reason you expected. You write just the bare minimum amount of code necessary to make that test pass. Once that test passes, then you can either refactor your existing code, so you can look for ways to make the existing code better, to restructure things without altering the behavior, or you can go back, get another requirement, write another test. So that's the pattern we go through. That pattern is called red-green-refactor. So if you hear that, that's what they're talking about. Red, that's my failing test. Green, all my tests pass. Refactor, my test pass, and now I'm going to go into the code and restructure it to try to make it better without actually changing the functionality. So let's look real quick at some of the headaches around doing this type of thing. So when you start doing interaction testing, frameworks like mock make it a lot easier, but this is still pretty painful. You know, I've got to make a mock object for console. I've got to make one for transaction. I've got to pass them into my calculator, and you'll start seeing this pattern everywhere. You know, if you don't get a tool that will help automate some of this and take some of the pain out, you're going to be doing this exact same pattern on every single class you test if it has dependencies on something else. You're going to be making mock objects. You're going to be, you know, passing them into your system under test. You're going to have to remember to keep coming back and updating this constructor to pass it on, you know, new services that it takes a dependency on. It just gets kind of painful. You may have also noticed that it's a little bit tedious to have to remember every time I make a test case to come back and add that test attribute. It's pretty easy to forget to do that. That's another reason it's very important to run your tests first and make sure that they fail, because you may have left that attribute out. You know, so if you leave that attribute out, you're not going to get a failing test because your new test isn't even going to be run. So let's skip forward. Yeah, actually, we'll just do this. So that's where the SpecsFor framework that I have, that's where that comes in. So SpecsFor basically is a framework that was grown from a pattern that I saw repeated on pretty much every project I worked on for about a year. It's, you know, stuff that we'd implemented to streamline unit testing, and I finally got tired of maintaining like 3 different versions of it, so I just rolled it out into a framework. So let's go ahead and add a reference to that.
This sits on top of
Yep. Yeah, right now SpecsFor is dependent on NUnit. You can only use SpecsFor if you're actually using NUnit. I do have plans to kind of abstract that away so that you could use a different testing framework. And I've written SpecsFor so that it works with MS Test before, just because that was the project. You know, they used MS Test already. But for right now, the official branch only supports NUnit. So let's look at how we could rewrite some of this code, some of these same tests using SpecsFor instead of manually doing stuff with mock and all that. So let's start with, so I'm still going to make a calculator specs class. And now I'm going to take advantage of, let me pull those in actually. So SpecsFor is a class library, but it's also, in addition to that, some Resharper live templates. Anybody done much with the Resharper live templates? Yep. Anybody, how many people in here are using Resharper? A few people, yeah. Yeah, so I love Resharper. If you're doing anything with Visual Studio, you should definitely look into it. If you can get your employer to pay for it, that's great. If not, it's really worth the money anyway. But SpecsFor also comes with some live templates that you can plug in that streamline some of those things like creating test fixtures, creating test cases, just gets it down to a few keystrokes to set all that up. So I'm going to go ahead and import the live templates that come with the NuGet package. And I'm actually going to edit them just a little bit to make them simpler. SpecsFor is pretty flexible as far as how you establish context and all that. So for today, I'm just going to go with the simplest way to use it. So I'm going to import that one. Let me grab one more. Actually, we don't even need the file one for now. But so I just imported a couple of Resharper templates. So one of them is when. So I'm getting ready to set up a new case here, a new test case. If we think back, our first requirement was when adding an empty string, it should return 0. So we say when adding an empty string, and this is specs for a calculator class. Then it returns 0. Oops. I deleted the class I was running tests under. Alright, so what I've done here is I've made kind of a more behavior-driven development style specs class. So I have a specification when adding an empty string. Here's the implementation of that. Then I expect this to happen. So I use some Resharper live templates to generate this for me. But where's the calculator in all this? You know, there's no code here to actually initialize the calculator. You remember the calculator actually has, if we go and look at it, it actually has several dependencies, right? We have a dependency on console. We have a dependency on this transaction service. I'm not having to set any of that up anymore in my specs. I have this system under test class. That's my calculator. It's already set up and ready to go. I didn't have to do anything. So let's look at what's actually happening. So next, let's say the user passed in an empty string. We also expect that to be logged to the console. So we're going to add another test case. Then it should write 0 to the console. And we're going to take advantage of a base class method from SpecsFor. We're going to ask it to give us a mock object for console. And then we can just, at this point, we have basically that mock console that we had from our old unit tests. So we can call verify console right line 0. And that's it. So I'm no longer having to manually create those mock objects and track them. I can just let SpecsFor do it for me. Same sort of thing. So the transactions, we should be recording a transaction. So then it logs a transaction. So get mock for my console. Verify. Look, we don't want the console, we want the transactions. Same thing. So all that mock setup is all being taken care of automatically under the hood. And SpecsFor is taking care of injecting those things into our system under test automatically. We don't have to do that by hand anymore. So let's say that we want to add another dependency here. I'm kind of breaking away from the test-driven pattern a little bit just to show this kind of what SpecsFor can do. So let's say we have some dependency on iUser. So we expect the user to be injected. So right now, if we were doing the old style unit tests, we would have a compile error, right? We'd have to know to come back and build up a new mock user object and pass that in. We don't have to do that with SpecsFor. SpecsFor automatically is going to take care of that new dependency on the iUser. So let's actually make a new requirement now. We actually want it to tell the user hi. So then it tells the user hello. So get mock for console, verify, hello. All right, so test fails because we haven't implemented that functionality. Let's say that the username here is actually going to come from something else. Let's say that's actually going to come from our user object here. So we can go ahead and let's try to make this pass. So let's say console.write line hello. Maybe I need to store that, don't I? So we have our user stored in a field. Now we can say hello to the user. So let's just say that there's a name property on there. All right, so when we actually run our test now, we get expected to be, we expected write line to be called. We expected it to say hello Matt, and instead what it got was hello nothing, empty string, right? So that's because SpecsFor is passing in a mock for this user. So by default, that mock object, when the name property is accessed, that name property is going to be null. It's just going to return null for it. So what can we do? We want to set up some behavior on that mock object. Well, the right way to do that in SpecsFor is to create a given method. So given is what we're going to use to establish state before we actually run our test case. So in this case, we want to set up that user so that it actually has a username. So we're going to use mock again. We're going to say, give me the mock for the user, and I want you to set up a get on the username property, on the name property. I want you to return Matt whenever somebody calls the property. So run this again, and our test passes. So it actually is now writing, hello Matt to the console, and it's able to do that because we've attached behavior to our mock object now. We've told that mock object when somebody accesses your name property, return the string Matt. So now in our calculator, when this actually runs, it's got our mock user object. It's accessing the name. That name has been configured so that it will return the string Matt. So our test passes. So we still, even though we've got quite a bit of interaction with external pieces of the application, we're still able to write a unit test here because we're able to abstract and use mock to break those dependencies apart and substitute mock objects anywhere that we have a dependency, and we can attach behavior to those mock objects. So any questions so far on that? Sure.
Is it the SpecsFor only for the AD, or it looks like
Yeah, I do behavior-driven development style testing. Yeah. So there's a lot of confusion around the difference in the acronyms, TDD, test-driven development, and BDD, behavior-driven development. The guy that actually coined the phrase BDD, I can't remember what his name was. Who? Excuse me? Is that it? Maybe that was there. I was reading something where he said, he was teaching a class on test-driven development, and he was using the terminology arrange, act, assert. So arrange objects into some state, act, call whatever method you're testing, and then assert, what is true after that runs. And he said, it just wasn't clicking. It wasn't clicking. People weren't getting it. And so one day, instead of calling it arrange, act, assert, he started describing it as given, when, and then. So given some state, when this happens, then this is what things should look like. And that's what became behavior-driven development at the beginning. That was just it. That was BDD, was just that change in terminology. Now it's kind of expanded out a little bit. People are starting to use that, that to describe automated acceptance testing a lot now. But that's not really what BDD is. BDD really is just that subtle shift in terminology into writing tests that read, when this happens, given this state, then these things should occur, as opposed to writing assert that, blah, equals whatever.
The reason I asked this question is the BDD spec, whoever writes it, probably a UAD team can sit and write the BDD test case in the BDD format, where like given a feature, when I order an item, it should go in the car, the end user should be there in the car. So these things, you get them by a set of teams, and then you take that and you write a test case on top of it.
Yep. So yeah, you can do that, and there's other frameworks. Some of them are not .NET, but there are frameworks that do take that exact approach. Somebody else kind of writes your BDD style test, and they generate code off that, and then a developer comes in and fills all that in. So yeah, that's definitely one approach. This framework, though, is really geared towards trying to make the life of the developer as easy as possible. The Resharper template, so you don't have to remember to add test attributes, and so that you can generate the stub for your specification classes. The framework underneath that's taking care of building up these mock objects and substituting and hooking all that stuff in. That's really what SpecsFor is about. Yeah, question?
Yeah, you said you're tied into the NUnit testing. Are you tied into any particular mock framework? Or?
Yep, right now it is tied in specifically to mock, so it will not work with, there's other frameworks like Rhino mock and Just mock and things like that. It will not work with those today. It's on my to-do list to abstract that out, though, so that it will pick up whatever mocking framework you have referenced in your project and use that. So it's on the to-do list. I don't know when I'll get to it, but it's on there. Question?
About the same thing for StructureMap.
It's actually using StructureMap under the hood.
That's what I'm asking.
Oh, so to swap that out?
Yeah, I'll use it out.
Yep, I've actually, another version of this that I'm having to maintain separately actually uses an inject auto mocking container under the hood. I'm not exactly sure how I'm going to, bridge that gap. I may actually have to fork the framework and kind of have a release for, StructureMap, another release for Ninject and something like that. It can be done. It's actually pretty easy to swap it out if you want to, fork the code and do that.
There's a project on Complex, I think, that sort of like an IOC container obfuscation thing.
Yeah, that abstracts everything away. Yeah. Mm-hmm. Yep. Good questions. Yes. Sure. It does kind of increase the verbosity of the code a little bit. Yeah, there's more code to specify these simple cases. In practice, in the real world, though, I found that it actually saves lines of code because I'm not having to. So let's go back and look at this real quick. Our calculator specs. So, no, it's fine. So, if we did this separately, we're going to have this when. This action is going to be in every single one of our tests. Ideally, we should be testing that the right thing is being written to the console, it's being logged to the transaction, and any other side effects are, being met. That's going to be repeated in every one of our test cases. And if we want to change that around, if we need to change, maybe refactor that method or something like that, we've got to change it everywhere. or if we need to start passing in a parameter, we've got to go back in all of our tests and pass it in everywhere. This cuts down on the duplication a little bit. So the net result is hopefully that you're going to write fewer lines of code with this approach as opposed to manually writing test cases.
SpecsFor doesn't help you with adding all the interfaces to constructor and anything like that, right?
No. So yeah, right now we could go in here and say, then it calls some service. So we could say get mock 4 iService verify whatever. So we could set up some expectation, and SpecsFor is not going to complain. SpecsFor doesn't care that the calculator doesn't actually pull that interface in. It's going to still complain that this requirement, the thing we set up on our mock, wasn't met, but it's not going to tell us that it's not even being injected into the calculator. So yeah, it still falls back to you at that point to look and see, how does my calculator actually get access to that interface? And SpecsFor is built on the assumption that you're going to do constructor injection, which I think at this point is pretty much ubiquitous in the .NET community. I think for the most part, everybody's using some kind of IOC container and doing constructor injection. Unless you're doing classic ASP.NET, and then you may be doing a not dependency or constructor injection, you may be doing property injection or something like that on your web forms. But. Sure.
Does SpecsFor supports writing your test case with pure injection, and it gets converted into like the empty stuff, and then you go and fill up your stuff?
Yeah. So the question is, can you write your specs kind of just in English first, and then have it generate the stuff for you? Not right now. If that's something that a lot of people are doing with SpecsFor at some point, then that might be something I would look at. One thing I am looking at is trying to come up with some add-in that. So right now, if you're going to make a new test case, let's say then, and as you're typing out this sentence, you've got to remember to put underscores instead of spaces. Right, and I find that to be a huge pain. I've seen add-ins where people basically they end up with a template that looks like this. They write their sentence, and then when they hit enter, the add-in automatically converts it to a method with underscores, a valid identifier. So that's something that I am looking at actively right now. I just have not found anything that does not require a Visual Studio add-in. I really want something that I can plug into Resharper or something like that. So good question. So let's see. I think we got time. I can show you one convention. So say I've got a bunch of these different specs here. So maybe I've built up, when adding an empty string, when adding, two numbers together, all these different things. I don't want to have to keep setting up this mock behavior every single time in every one of my specs. So there's a few different ways that you can encapsulate this in SpecsFor. The one way is you can actually put an attribute on here. You can say given type of, user exists, and we can make a class that's going to establish context. So we can actually tell SpecsFor that run this unit test given that this state's already true. And we can actually specify multiple states like that. So we could say given the user exists, we could say given, database configured, whatever. We can actually specify all these different contexts that need to be run before our unit test actually runs. That works. That's a newer feature in SpecsFor. I still prefer the older method of doing things, which is where you kind of push down that behavior into a nested class, because it reads a little bit better. So what we would do in older versions of SpecsFor, we would say given the user exists, and we would have a given class, and underneath that, you'd have an abstract class that actually inherits from the SpecsFor class. And here is where we would put our given. So instead of having this repeated in every one of our specs, we just put it here, and we hide this bit of code. And our tests read a little bit better now. It says when adding an empty string, given that the user exists. So you end up with even a little bit more of that behavior-driven development style vocabulary in your test. And it gives you a nice place to put, expectations and that setup that needs to happen across a whole suite of test pictures. Yep, so good questions. So, giving credit where credit is due, we kind of ran through a little bit of the string calculator kata. Yeah, that's what I was going through, or what our Kitty there was giving us requirements from. Check out Roy. He's a testing ninja. He's written The Art of Unit Testing. He does a lot of coaching on how to do unit testing. And he's actually got the string calculator kata. He just came out with a second part of that series just like a couple of weeks ago. So check out his site. The string calculator kata is a great thing to kind of run through if you want to get, really get test-driven development. Just run through that a couple times a week. That'll really help. And also got to thank Christopher J. Smith for creating a picture of a cat that was exactly what I had in my head. All right, so if you want to know more, if you got any questions about SpecsFor or just test-driven development and practice, feel free to hit me up on Twitter or check out my site. If you want to grab the SpecsFor code or the assemblies, you can go to specsfor.codeplex.com, or if you just want to grab the package, it's on NuGet. So that's it. Thank you, guys.